Okay. Good morning, everyone, and welcome to our last plenary for this conference. We've got a bit of a slightly different flavor now of presentations. We're, I think, more on the geological side and a bit more about finance. So our first speaker is not with us physically. There's a video that he recorded for us, and then he'll be available for the Q&A part. So Professor Liang is a professor in sustainable construction and infrastructure transition at UCL. And then before he joined UCL, he was a senior lecturer in the Energy and Finance department at the University of Edinburgh. You'll see many sort of Edinburgh and Imperial links here today. He was a PhD. He has a PhD in energy policy and finance. And he's the general secretary and co-founder of the UK-China Guangdong CCUS Center. He's an expert panel member in climate finance for the Chinese government. He has been the PI of climate finance and CCS related projects within working for the World Bank and Asia Development Bank. He's been advisor to a number of firms on climate strategies. I won't read them all, there's a very long list. And he's recently started leading the provincial CCUS planning task group for Guangdong and Ningxia in China. So I think if we can roll his presentation now. Thank you.
Dear colleague at the UKCCS Research Center Spring Conference, and I would like to use this opportunity to introduce CCUS development in China, and apologize not being able to attend in person due to a conflict schedule. So I'm Liang, professor at University College London, and also Secretary General of the UK-China Guangdong CCS Center, established 10 years ago between Chinese parties and the UKCCS Research Center and the Scottish CCS. So CCUS has a growing important role in China's because China announced carbon neutrality in 2020. Since then, and CCS is considered as has a momentum role for achieving low emission or net zero emission of when using fossil fuel. But at the same time, to achieve carbon neutrality, and many experts believe the important role of delivering negative emission technology. So CCUS with biomass, direct air capture, and potentially cement sector could be quite important technologies pathway to contribute to negative carbon emission. And there are also growing interest on industry decarbonization, like cement, steel, and petrochemical sectors. So CCUS projects in China, the number has grown dramatically since China announced a carbon neutrality target, and the total scale has already achieved 9 million tons per year, with projects spread over 24 provinces across the countries. And the largest share of CCS projects are located in the northwest of China and the Shandong and the east of China. And like surrounding all those spaces, there are many CCS projects. In Shandong, there's 1 million ton carbon capture and storage with UR projects now in operation, run by Sinopec. In Jiangsu, there are 500,000 ton carbon capture at the Taizhou coal-fired power plant. There are also a few multi-million ton projects are in construction or the planning stage. So the total number of CO2 being captured and stored will still growing dramatically in the next few years. So in the power sector, China each contribute the highest amount of carbon emission in China, and the Chinese power sector alone may contribute to more than 8% of global greenhouse gas emissions, as it contribute to about more than 4 billion tons of carbon emission. So traditional post-combustion capture with amine solution is the main technology. There are different type of novel amine now being tested in China, in like phase change amine and some solution to help contribute to reclaiming amine. And other novel technology like membrane pre-combustion capture, oxy-fuel, chemical looping, physical absorption, MOF technology are being piloted and tested at a quite large scale. And not much progress has been made on oxy-fuel and the pre-combustion IGCC in the last few years. It still stay as what it looks like 5-10 years ago. But I believe all technology may have potential to be scaled up in the next few years. And in addition to coal-fired power plant, there are also interests from capturing CO2 from natural gas power plant. So there are some small pilots being deployed across the country. In Guangdong province, one of the UK-China collaboration efforts to build a carbon capture testing platform, and the plant has now already tested 7 different carbon capture technologies, and is still carry on functioning quite well. And if colleagues in UKCCSRC have new idea want to be tested, can submit a proposal to us. Carbon capture in cement and steel sectors has received dramatic interest, but the economic recession has constrained the funding span in both sectors. In the cement sector, Conch Cement launched the first carbon capture pilot in 2018, and United Cement Qingzhou has started construction 200,000 ton per annum carbon capture with oxy combustion process. In the steel sector, Baowu Steel, the largest steel group in the world, is constructing China's first large-scale carbon capture project in Baotou. Bao Steel is not Baowu Steel, sorry, in Mongolia, with amine-based capture system. Some of the CO2 will be used to react with steel slag to develop some utilization products. In terms of CO2 storage, there are both onshore and offshore CO2 storage being deployed, in addition to some earlier EOR, enhanced oil recovery effort. So remember, coming back to 2011, Shenhua capturing 100,000 ton CO2 per year from coal to liquid direct liquefaction plant in Mongolia, and running for 3 years, which is the first pilot scale deep cyanide formation storage projects, and currently still in continuous monitoring phase. In South China in 2021, Sino initiated China's first offshore CO2 storage project at the Erping 151 oil field, which captured and stored 300,000 tons CO2 per year. There are also some other plans to scale up cyanide formation storage in Shanxi and in other provinces. And in Guangdong province, for unconventional storage, Guangdong province piloting carbon mineralization storage in basalt. So this is some of my colleagues now are working, and we are already drilling into 480 meters by yesterday to look at sampling of the basalt, and we'll use a well as a monitoring well after the injection started. We take some sample out, and now we try to verify whether the feasibility of injecting CO2 to basalt for mineralization process. CCS development in China is also shift from single demonstration project to clusters. So in 2022, 2 oil companies, CNOOC and Sinopec, both announced large-scale CCS projects, one in South China in Guangdong, in Dayawan Basin, which is 10 million ton scale, in collaboration with ExxonMobil, Shell, and Sinopec announced an MOU with Shell, Baowu, and BASF in Shanghai to conduct cooperative research and jointly launch China's first open 10 million ton CCS project in East China. There are many other CCUS clusters, like PetroChina has working on China's first CCUS hub in Zhenghe Basin in Xinjiang, northwest of China, and also have planned CCS hub in Changqing oil field in Shanxi, Gansu, and the Daqing oil field in northeast of China, and Dagang oil field in Hebei province. Recently, CNPC also signed the Hainan Low Carbon Cooperation with BP to build the Hainan CCUS hub. So in Guangdong and Shanxi and Ningxia, these three provinces has appointed our center to be advisor to make provincial CCUS planning and developing provincial CCUS cluster. So for example, in Guangdong, we complete the study which cover 587 million ton carbon emissions from power industry, manufacturing, construction, transportation, agriculture. And we look at 199 stationary emission sources in the province and develop 4 CCUS cluster in the west of Guangdong, in the west of Pearl River Mouth Basin, and the east of the province, which mainly relying on offshore CO2 storage formation to sort out the CO2 in the longer term. So CCUS in China is not only the cost, given the experience of developing solar PV, wind turbine, energy storage, battery, electricity vehicle industry. I think there are growing understanding on the potential role of CCUS brought to industry and economic development, in addition to potential emission reduction. So between UK and China, working with ARC21 and many of our Chinese partners, we have identified potential collaboration opportunity between China and the UK in carbon capture, carbon transportation, carbon usage, and carbon storage. As you can see, there are many firms from China and from UK could potentially complement with each other in terms of technology, funding, ideas, strategy to jointly develop successful CCS project and achieve cost reduction in the long term. So I don't want to expand it very detailed, but like a carbon capture market, UK has strengths in like in developing heat exchanger, column internal flue gas blower filters, and also potential aiming solution, absorption material, and membrane technology. And indirect air capture, this is another area UK company could innovate and collaborate. In carbon transport market, there are CO2 pipeline design, operation, and maintenance that could potentially have a UK company can be involved. In carbon utilization market, CO2 synthetic for jet fuel, methanol, methane syngas, degradable plastic, there are potential ways to achieve CO2 utilization, while like synthetic for jet fuel may have potential market in wider prospect in Europe and around the world as well. So there are also potential opportunity between on CO2 storage market, on reservoir design, engineering, marine, subsea, and also of CCS training capacity building. So we are developing a report with ARC21 and the UKCCS Research Center, and feel free to download it from UKCCS Research Center if you have interest. So international collaboration also is a carry on to be one momentum driver for CCS in China. And last year, between United States and China's joint statement on climate change, CCUS has been highlighted, and the US and China agreed to jointly develop 5 CCUS projects at large scale by 2030. In Guangdong, we have set up the collaboration between Guangdong Electric Power Design Institute and many local industry partner with UKCCS Research Center and Scottish CCS. So in January, we were delighted to extend the collaboration for another 10 years between our initial funding partner. And in reality, we also expand our footprint beyond Guangdong province. We have actively developing planning and projects in Shanxi, Ningxia, and also in Macau. So well, we hope to welcome you in Guangdong and welcome your suggestion and idea to carry on working on CCUS together. And thanks for your attention.
Till the end. Our next speaker is Neil Wildgust, who comes to us from Carbon Management Canada. So Neil has been in this industry for 35 years, but probably the last 20 of them pushing for CCS or championing CCS. So Carbon Management Canada basically helps organizations and governments, industry in reducing emissions and trying to meet their net zero goals. Prior to joining CMC, Neil was the Director of Cordilleran Research at the British Columbia Geological Survey. He consulted independently on CCS and risk management. He's also held past roles within the IEA GHG R&D program, the Petroleum Technology Research Center, leading the IEA GHG Weyburn Midale program, the Petroleum Technology Research Center, the Global CCS Institute in Calgary, and the Energy and Environment Research Center in North Dakota. He's been associate editor of the International Journal of Greenhouse Gas Control and received the Plains CO2 Reduction PCOR Partnership Pioneering Award in 2015. It's a long CV. Neil, please. The clicker's there.
So good morning, everybody. I'd like to start with a little caveat. So I am Canadian, a newly minted Canadian, actually. I got my citizenship last summer after living in Canada mostly for the last 12 years. And I run a Canadian company, but I'm not speaking, and I'm talking about Canada, but I'm not speaking on behalf of Canada. So that's my disclaimer. I just want to make that absolutely clear. What I want to do over the next 15 minutes or so is just give you a clue as to what's going on in North America, mainly Canada at the moment with CCS deployment, talk a little bit about some of the remaining challenges, and then I've got a self-indulgent slide on Carbon Management Canada at the end. And we are a non-profit research organisation. So to begin with then, we have 3 operational, commercial, large-scale CCS projects in Canada. And these have been going for some time. So the Shell Quest project has been operating for about a decade in Alberta. And that stores up to 1 million tonnes of CO2 per year that's sourced from the oil sands industry, from upgrading of oil sands. The Alberta Carbon Trunk Line in the same area is a little different. It captures up to about 1 million tonnes a year from both an oil refinery and a fertilizer plant. And that CO2 is piped to the south of the city of Edmonton into an enhanced oil recovery field. And then in Saskatchewan, the neighboring province in the middle of Canada, the joke about Saskatchewan is that it's easy to draw but hard to spell. Saskatchewan basically is a pretty empty place. There's about 1 million people in, and you could fit the UK within that province quite easily. So Canada's a pretty big place. The Boundary Dam project captures up to 1 million tonnes a year, probably doesn't achieve that too often, but it captures up to 1 million tonnes a year from coal-fired power. And that was really the world's first project with coal-fired power post-combustion capture at any kind of scale. So these are 3 pretty big projects. None of them would exist without government grants. They were all heavily subsidized to get into operation. And I just wanted to mention as well, as most people in this room are researchers, so a bit of an appeal really in that, I'm guessing a lot of you are relatively new to CCS, and there's a handful of us who are veterans of CCS in the room. And 10, 15 years ago, we always used to make jokes when we turned up to conferences that it was the usual suspects. No matter where you went in the world, you always saw the same faces. I often saw John, Stewart, etc., and Gardner as well. But, it's good. So it's good to see I'm in a room where I basically don't know any of you really. But when you're starting your research, don't lose sight of what's already been done, because it's very easy, I think, to think that this is new and the problems are new and they haven't been looked at in the past. But there's huge bodies of knowledge out there on CO2 storage and public outreach, for example, or the technical aspects of CO2 storage that get lost. Boundary Dam supplies most of its CO2 to the Weyburn oil field just to the south. And the reason I went to Canada 12 years ago was to manage the last 2 years of a big international program that was linked to the Weyburn oil field. It used that operation as an analog for large-scale dedicated CO2 storage. And one of the big learnings from that project was around outreach, because there was an accusation of a CO2 leak there. And it made international headlines and was used by people to say that CCS doesn't work. So a huge amount of effort was put into disproving those allegations, and we did. And I can talk offline about, I could use a whole hour just telling you what happened in that particular case. So we have those 3 projects that were established with government grants. We're in a situation now where we have new incentives in Canada to try and push CCS forward. So the first one is there's a federal tax credit, and this is basically to support CapEx investment in CCS projects. So you can see the numbers there. A couple of things to note: from 2031 onwards, those numbers get halved, and from 2041 onwards, there's nothing at the moment. So that obviously the intention is that that's to try and push projects towards deployment. And Alberta has just announced 12% additional CapEx credit on top that's stackable on these federal incentives as well. One interesting difference is that EOR is not included in the federal tax credit, but it is eligible for the 12% that the province has announced. So in addition to those tax credits to support CapEx, we also have federal carbon pricing in Canada. By 2031, a tonne of carbon will be worth $170 per tonne, Canadian dollars. So that's quite a significant, and that's again stackable on top of the CapEx assistance. So there's quite a lot of potential incentive there. There's still some details of this needs to be published. There's also a contracts for difference option as well, which someone in Alberta, I think Entropy has recently taken advantage of on a 200,000 tonne a year capture project. So things are moving. There's still uncertainty on how some elements of this are going to work at scale. But there's significant rewards, and they have driven a lot of activity, if not yet final investment decisions. Now, I should mention that in Canada, the provinces have an awful lot of autonomy, more than US states do. So over energy in particular, energy policy is largely in the remit of the provinces rather than the federal government. And in Canada, or in Alberta, we have a very conservative provincial government. In Ottawa, we have, let's say, a centrist government who are portrayed as being quite left-wing by their opponents. So there is a lot of disagreements about energy policy that buffet people and projects around, unfortunately. Alberta has its own version of the carbon tax and cap and trade system, which effectively replaces the federal system. And the Alberta system is designed to be more flexible and encourage more wide-scale industry participation. And the monies that, it's actually been in existence since the late 2000s. It's one of the world's oldest schemes. And so, you know, there's some differences with the federal scheme as well, but there's a lot of squabbling about the detail. And I want to just divert to the US briefly, because I did work in the US for 3 years for the Energy and Environment Research Center. When I took that job in 2016, Donald Trump was elected about 2 months later. I had a slew of emails from concerned friends and family saying, well, you're about to lose your job in CCS research, bad luck. Well, actually, it didn't really work out that way, because once he was elected, his senators got to work and said, you know, you really need to support the R&D and the related efforts that are going on with CCUS. So in fact, the Trump administration raised quite considerably the 45Q tax credits. And then under Biden, they've increased again. So you can see at the bottom of the slide, $85 a tonne for saline storage, $180 for saline storage with DAC. And then for EOR is also included as well. So those $85, $60 and $60 incentives have really created a surge of projects right across the US, and I couldn't even show them on a slide. If you're interested, there's good databases out there. NETL or the Clean Air Task Force or the Global Institute have good publicly accessible data on all the projects that are being proposed. A lot of them still haven't reached FID, some have. The ethanol industry, for example, is relatively cheap to capture CO2 from, and they've been moving forward as well with this. But if I was to look into a crystal ball and try and predict what's going to happen, I think those numbers will rise again, because with inflation over the last couple of years, the cost of capture has gone up. And so a lot of people are now saying the 85 and the 60 numbers aren't enough. So it remains to be seen. One thing I'd put money on if Donald Trump gets re-elected is I think you'll see EOR brought up to parity with saline storage, so that whatever the number is, I think they'd be the same. And that's a firm push that I've seen from the fossil fuel industry in the US. So in Alberta, because of the incentives I mentioned before, there's a lot of proposed projects in Alberta as well. The red dot is Quest, that's in operation. And then the green and the purple, there's 26 proposed projects in all. And the only difference between the green and the purple is that they were slightly different phases of announcements. But essentially all those 26 green and purple dots are projects which are moving forward at different paces. They're all megaton storage projects. Most of them have multiple capture sources. None, as far as I'm aware, none of them have really reached an FID yet. And if I could describe the situation, it's a bit like a Mexican standoff, like in The Good, the Bad and the Ugly, the movie. You've got industry, the provincial government and the federal government all staring at each other, figuring out who's going to buckle and increase the price or deploy projects or whatever it is. Now, I think going back to the research element, I'm a bit biased because I run a research company, but storage is taken for granted. And I've heard it here, to be honest, over the last day and a half, a lot of discussion around the cost of capture, etc. Storage is a proven technology. We've got Quest, we've got Sleipner, we've got all these others. So we know that it can work, but that doesn't make it easy. Okay, proving up and de-risking any storage site takes a lot of time, a lot of effort. And site projects can fail because the storage doesn't match up to the ambition. So it's really important that storage research is supported, applied research that helps move projects forward. And I'd urge all of you who are interested in storage to go onto the US DOE NETL websites and look at the Carbon Safe program in America, because that's pumped a lot of money into de-risking storage projects with industry and with research centers as well. And I wish we had the same kind of thing going on in Canada, because it would make a real difference. In Alberta, most of these projects are going to use the basal Cambrian sands, which the Quest project already uses. So it's proven to some extent. But one of the big research questions that nobody talks about very much is, if a majority of these projects move forward and you've got all these megaton storage hubs in Alberta and most of them are using the basal Cambrian, you're going to get pressure interference between these different projects. And we don't yet have a very good idea of how significant that's going to be and how much it might reduce the injectivity or the capacity of those storage projects. So again, that's another example of there's lots of stuff we still don't know enough about that needs to be researched. Okay, and then for the shameless self-promotion of CMC, our unique selling point as a research company is that we have our own site. It's about a 2-hour drive from Calgary, and hopefully those of you who are going to the GHGT conference in Calgary later this year will get a chance to come out and see the site, because it's one of the official tours. We have our own well with no commercial partner or sensitivity. We inject a small amount of CO2, about 100 tons is injected at 300 meters depth. So it's an analog for leakage from a commercial site. And we have a whole plethora of monitoring technologies deployed there. We have 22 industry partners. So it's well supported and they see the value of the research that we're doing. But we also have ambitions to develop the site. We've got a long-term lease. It's a big site, about 500 acres. And that current footprint of our activities you see there at the moment are relatively small. So one of the ideas that we're pursuing is to actually build a direct air capture test centre on the facility. We have the room to do it. We've got the water supply, we've got electricity, and we can get green electricity from nearby sources. So the idea is that we would build, if you like, a series of parking bays that direct air capture people, excuse me, can come into the site, plug into the system and test their pilots. And we would have a deep well to permanently store the CO2. So I'd say anybody who's interested in finding out more about our research site, would like to collaborate, please come and talk to us. We're very, very happy. And we do have a number of European and British organisations who've already collaborated and worked on our site. So we're always happy to develop those relationships. And then I'll just leave you with the parting thought that, yes, in the US particularly and in Canada, we are moving towards wide-scale deployment. And I'm optimistic about that, but there are still challenges, particularly on the policy incentives side. And don't take storage for granted. Okay, thank you.
Thank you very much. And our final speaker today is Professor Toru Sato from the University of Tokyo. He is a professor at the Department of Ocean Technology, Policy and Environment. Toru did his BEng and MEng at the University of Tokyo, but he did his PhD at Imperial College London. So he's been involved in looking at CO2 subsea bed geological storage for the last 25 years. This includes looking at the environmental impact of CO2 subsea bed geological storage, development and application of multi-scale ocean models, development of dissociation and formation models of methane and CO2 hydrates, design and feasibility study of CO2 storage in the form of gas hydrates, and proposing effective indicators of CO2 related concentration in seawater. So Professor Sato, please.
Well, thank you, Abby. Good afternoon, good morning, everyone. I'm Toru Sato from University of Tokyo. Then today I will talk about the situation of CO2 in Japan. So my talk had two aspects: recent movements of CCS in Japan and the challenges of CCS in Japan, particularly the regulation about the CCS. Well, in 2020, the former Prime Minister Suga declared carbon neutral in 2050. And actually he stayed just for 1 year to his position, but within that 1 year, he made very big, achievement because this made a lot of change to CCS. Then actually, we will have CCS Business Act. This was permitted, approved by the cabinet last month. Then will be submitted to the Diet, Japanese Parliament, in May. So actually, I'm not good at writing about legal issue things like that, but so I translated it because this is just a draft. So only Japanese version is available in internet. So don't believe this is correct wording. But the important thing is, Minister of METI is Ministry of Economy, Trade and Industry, appoints the possible reservoirs as a special area. Then he will give the right permission of the test drilling and storing CO2. And another important thing is, the operators must make the reserve funds, funds for the monitoring after closing their wells. So I don't know how long, but after closing the wells, finishing the injecting CO2, maybe some decades. After some decades, you give the right, the obligation to monitor CO2 to the governmental research institute, JOGMEC. So, and JOGMEC will succeed the operations of monitoring and by receiving the money from the operators. This is the long-range roadmap of Japan. So we'll start the CCS business in 2030. Then the target is in 2050, 0.1 gigaton to 0.2 gigaton. So because the total amount of Japan's emission is 1 gigaton, so 10% to 20% will be covered by the CCS. This is good expectation of to CCS. And we have the actually industrial consortiums to store CO2 in 5 big sites and also 2 export ports. So because capacity to store CO2 is limited. I mean, physically we have a lot, but socially it's quite limited. So that's why we need to export CO2 to the the other Asian countries like Malaysia. So because Malaysia has a lot, oil and gas field, and they actually welcome the CO2 from Japan to store their depleted oil field. So next topic is challenges of CCS in Japan. So I think we have 4 big challenges. Storage capacity, as I said, but we have the another option, exportation of CO2. And the second one is cost burden. Of course, it costs a lot. So, but the Japanese government established 2 big funds. One is Advanced CCS Business Fund. Actually, this is my translation. Don't believe this is correct. And Green Innovation Funds. So in these, I mean, the government actually thought about these things quite, how to say, sincerely, and they actually gave the answer to these challenges. But still, we have 2 more challenges: local public acceptance and deregulation. So today, because of time is limited, so I talk about only deregulation. So we have the Act on Prevention of Marine Pollution and Maritime Disaster. So in 2005, following the London Convention, Japanese government, Ministry of Environment, made a new act, add something to this act about CO2. So the monitoring of CO2 in the sea is mandatory. That's a good, important point. Then this is made by Ministry of Environment, and the driving body of the CCS, Ministry of Economy, Trade and Industry, METI. METI is the driving force of the CCS in Japan. Then they entrusted Japan CCS Corp Limited to do a demonstration project in Tomakomai in Hokkaido. Then amount is just 0.3 megaton per year. Sorry, total 0.3 megaton. So the amount is quite small, but this project is really important and pretty good, because this gave the government a lot of confidence about CO2, CCS. Then the point is, okay, the Ministry of Environment forced the operators to measure CO2, monitor the CO2 concentration in the seawater. Then, but CO2 is, changing a lot, because, it is used for the photosynthesis, and we do, respiration. So, the left-hand side, which is the vertical axis is CO2 concentration, and the horizontal is O2. So it's the relationship CO2 and O2 are similar, something like this. And using this relationship, Ministry of Environment said that, okay, we'll have the distribution, scattering of the data. So 95 first upper limit of the prediction line. So if the concentration seawater exceed this line, then you have to stop the injection. Then you have to monitor the CO2 concentration in the seawater again, and you have to check everything is all right for injection. Then actually this happened. So after the injecting CO2 in Tomakomai, in 2016 in April, then in May some data exceed the upper limit. Then the Ministry of Environment forced to stop the CO2 injection. Then it spent several months and quite a lot of money. So that's why we need to think about this. Then I'll talk about my research. It's about the ocean chemistry a little. Then you see, this is the how to say, some research and Ministry of Environment to refer to, but actually the variation of the PCO2 is this range for Tomakomai. So Tomakomai water, we have a lot of large variations. So this is because here Tomakomai, we have a lot of sea currents, and Hokkaido is quite cold area. So in the summertime, early summer, a lot of snow smells and snow melts. Then the fresh water goes into the sea, and that pH of the fresh water is quite low compared to the seawater. So that's why we have high CO2 concentration. But what's the concentration in seawater? You see, this is the CO2 concentration in the atmosphere. So it's, as you know, it's just a small amount. Then this is has a relationship with the CO2 in the water. But there are three shapes of CO2 in the water. CO2, molecular CO2, and two ions. Then the balance between them is determined by the pH. Okay, so this is, you see, the atmospheric partial pressure is proportional to the only CO2, molecular CO2 concentration. Okay, then actually this is the indicator determined by Ministry of Environment. So this line is not linear. It depends on the slope, depends on the pH, and so it should have a lot of variety. So that's a problem. Then what we thought is different indicator. So you see, if the water stays at the surface, they can exchange gases with atmosphere. So then, so this is the equilibrium concentrations, and they are, the real concentration in the sea, and A0, B0, the coefficient saturation, depends on the water mass and saturation of the concentrations. Then, okay, and this is the photosynthesis. So DIC, dissolved inorganic carbon, has a relationship with the DO. Then also we'll have the calcium carbonate in the sea. So they should be included in the new indicator. Then we made these new indicators. So if you calculate this, it's just function of the saturation, A0, B0, and temperature. So if you take the temperature in the horizontal axis, so it has one line, quite linear one line. And the variation is just depends on A0 and B0. So this is the result. You see, if you take the this old the traditional, how to say, the Ministry of Environment indicator, you have a lot of varieties. But if you use this one, new one, that's the coefficient of the correlation is quite small, and these red points exceeds 95% upper limit. But these red points is under the 95% of in the new indicator. So, but some here, you see some points exceed 95% of this one, new indicator. So, but if you use both, then the probability to exceed the upper limit is quite, small. So this is what I, suggested to the government at this moment. But still, some people think of why 95%? You can change it to 98% or so, right? But in that case, you can avoid false positive. But in the case of false negative, maybe you miss the leakage. So then I'm thinking using machine learning. You don't need to think about anything in chemistry. You just put data, then say, okay, this is leakage. Yeah, this is not leakage. That's it. Then this is at this moment, one of my students doing this one. But the problem is we need the data of leakage, but because we don't have any leakage anymore at this moment. So, but fortunately, we have the natural analogs because we have a lot of volcanoes in Japan, right? So then we go to the with the natural analog, then we still measuring the CO2 concentration there. That's it, thank you.
So happy to open the floor to any questions for any of our panelists. Do we have no questions? Everybody's tired. Yep, one in the back, thank you.
I have a question for Professor Liang, but if he's still there.
Just a second, sorry, for the microphone for the people online to hear you. Thank you.
Yeah, I have a question from Professor Liang, if he's still there.
Is he online? Can we pull him up? He's not online. He's
That's
not
okay.
online. Sorry.
No worries then, yeah. It was about the carbon captured by membranes on the scale of the membrane separation they are doing, but if it's not there, that's okay.
He's
no
not
problem.
there. Thank you. We've got a question down here, please. Down here.
Thank you. Edward Thomas from Viridor again. Just about the Canadian situation. There's a lot of progress being made in terms of carbon capture and storage, as you emphasised, in that side of things. But there doesn't seem to be a great deal of publicly available data from permitted, regulated emissions, as far as I can see. Am I just looking in the wrong place, or are the regulatory bodies just a little shy of putting this in on the internet?
Yeah. Yeah.
It's a good question, and I'm probably not the best person to answer that, being primarily subsurface focused. I thought they were available somewhere, but I'd have to talk to one of my colleagues and get back to you on that. So if you want to catch me afterwards, I can certainly ask the question. I think overall the emissions are known in Canada, and the federal government has its roadmap to, for example, they're aiming for 2035, I think, for net zero electricity, which is hotly disputed by Saskatchewan and Alberta. So I think the overall numbers are known and published, but the individual emissions from different facilities, I can't imagine that they're not available. It's probably just a question of where you're looking. So I can get back to you on that.
Neil, there's another question that's come up for you. It's asking if you see a future for CCUS hubs in Canada.
Yeah, absolutely. There are 26 proposed hubs in Alberta, as I showed on the map. If you ask me how many of those are likely to happen in the next 5 to 10 years, I'd say My guess would be about 10 of the 26. But, you know, that's open to debate. I think, you know, the incentives when you stack them all up at the moment are quite attractive, and they actually add up in theory to more than 45Q in the US. But there is some there is a lack of clarity on the detail on some of them, which industry is pushing very hard for. And of course, the other problem that I think is very acute in both the US and Canada is that climate change and the need to mitigate it is something of a political football between conservative and centrist or liberal parties. You know, it's very visible in the States, but it's there in Canada as well. So, for example, the federal conservatives have pledged that they will abolish the carbon tax if they get elected. So how that would then affect CCUS deployment and hubs and the viability of hubs, you know, I mean, that's open to debate. But that policy uncertainty because of changes of government really serves to encourage industry to delay decision making. So I think there's a lot of policy challenges still. And yeah, and don't forget the challenge of storage as well. Sorry.
Thank you. So I think G is back online if you want to re-ask your question. Yeah.
I mean, in the capture side, you mentioned capture by membranes. I mean, I just want to know about the scale of the capture by membrane that center is doing. I mean, if you can hear me. Could you hear my question?
We will find out shortly. No?
That's fine then. I can drop him an email. No problem.
We think he's hearing you, but we don't know. So there's another question that's come up about CCS at full scale in China in the next 5 years, from 27 onward, but I'm not sure if the panel is equipped to answer that.
I'll take a pass on that one.
Yeah, me too. Toby. Okay.
Thanks very much. Rebecca Bell from Carbon Capture and Storage Association. It's another question for Neil, I'm afraid, but what's so special about Alberta and Saskatchewan? Why isn't BC doing stuff like this, for example?
It's a really good question, and I meant to mention that and I didn't, so apologies. First of all, the geology in Saskatchewan and Alberta is very amenable to large-scale storage. The second reason is that both of those provinces have significant reliance on fossil fuels for power and as oil and gas producers as well. If you're looking at East, Central and Eastern Canada, you know, you've got hydroelectric power, you've got nuclear power. So CCS is not such big news out in the east of Canada, and it's struggled to gain a lot of attention. But for Alberta and Saskatchewan, ultimately, it's very important for business as usual to continue into the future. And then British Columbia is a little bit different again. There are some sources, not a huge amount compared to Alberta. There is pulp and paper there, which I was interested to hear some of the comments earlier, because I don't think that's really been, that industry in BC hasn't really thought about CCS very much as I'm aware. But really in BC, the challenge again is geology, because you've only got the northeast corner of the province on the edge of the large sedimentary basin where the geology is really ideal for geological storage. The rest of the province is pretty poor, and there are people trying to promote storage in other parts of BC, but there's a lot of hopefulness and pipe dreams going on there. So for example, there's a basin in the middle of BC, the Bowser Basin, which is being looked at, but it's heavily faulted. And faults are really the enemy of large-scale geological storage, mainly because they serve as, they create pressure compartments so that your storage capacity can be very limited. And so I personally, I don't believe CCS will happen in British Columbia at large scale outside of that small corner of the province in the northeast. Now, people are also in BC very interested in utilisation, and I saw that the EU is talking about, was it 200 megatons or more of CO2 utilisation in 20 years' time. I think personally that's incredibly optimistic, but I am a geologist, so you have to take my opinion with a grain of salt.
Thank you. There's another question for you asking if you know or if you have any updates you can share with us about the Pathways Alliance project.
Yeah, so the Pathways Alliance project in Alberta is 6 oil sands producers who are one of those megaton hub proposals, and they would store CO2 in an area called Cold Lake in the basal Cambrian again. And they've made sort of faltering progress, but they have just announced in the last few days that they are applying for planning permission, for the pipeline that will connect all of those 6 oil sands facilities into the proposed storage at Cold Lake. So they are making progress moving forward. But again, I think Pathways Alliance, I mean, there's 6 significant oil companies in alliance, so you can imagine that there's a lot of internal friction and debate that goes on between those 6 companies moving the project forward. But I think also there's, again, some comments I've seen in the media about Pathways commenting on the lack of clarity around some of the incentives. But they have made an announcement on the pipeline planning permission, so they do seem to be moving forward.
Toby?
Yeah, question on incentives for both speakers. I think you mentioned a CCS business fund in Japan. I was wondering how much money is in that, and if we have an idea of how many projects that could support of the ones that are proposed. And also in Alberta, maybe you covered this, but just wanted to get an idea of how significant the support from the TIER is. I think it's somehow linked to the federal carbon price, which is supposed to go to $170 per tonne in 2030. That seems very significant on the face of it, but I think it's maybe more complicated than that.
Well, you asked about the size of the budget or something. Yeah. Okay. I talked about 2 funds, and actually I don't know the first one, but the second one is Green Innovation Fund, and the total amount is $13 billion. So, but it's not only for CCS; it's for everything for green innovation, like offshore wind turbines or something. So it's a part of the. It's good to go to the CCS. That's the size of the kind of image of the size of the government spend money for CCS. May I answer? Did I answer to your question?
Yeah, I guess the question is whether any of this money is big enough to fund full-scale projects, or is it more research?
Well, I showed some, the industrial consortiums, right? And they are thinking to apply to the first fund, okay. CCS, Advanced CCS Business Fund.
Yeah.
So because the industry thinking seriously about CCS business, so which means that the government support will be enough.
Thank you.
Satisfactory.
Thank you.
Yeah, so in Alberta, the TIER fund is the federal equivalent to the it's the provincial equivalent to the federal carbon price, because Alberta wants to have its own system. So by 2031, CO2 will have a price of $170 Canadian dollars per tonne in the Alberta TIER fund as well. But it's a cap and trade system, and essentially emitters are allowed to have they're allowed to emit a certain amount, and then if they can actually reduce their emissions from their capped amount, and they generate compliance credits that can be traded then. So it is more complicated, and I apologize again, I have to plead, being a geologist, so I sometimes struggle with the detail of this stuff. I think on its own, it wouldn't be enough to incentivize CCUS, but with the CapEx assistance from the tax credits, then that could be enough in theory to make projects economic. But there needs to be more detail, I think, in some of the policies. And again, there's also this concern that a change of government would then radically alter the policies, and so industry is a little concerned about investing without policy certainty if there's a change of government. I think that's a big factor.
Thank you so much. Can I please ask everyone to thank our speakers today? And thank you.